So without further ado, we'll slide into our first presentation, which is from Abe Noe-Hays, the research director at Rich Earth Institute. He'll be presenting Tools in the Toolbox, Urine Diversion and Beyond. Abe is the research director at Rich Earth Institute and the chief technology officer at Brightwater Tools. And he has been professionally involved in resource recovering sanitation since 2001. He co-founded the Rich Earth Institute in 2012 to establish the nation's first community-scale urine recycling program, which includes a multidisciplinary research and demonstration effort involving farmers, scientists, planners, and volunteer participants, with the goal of developing knowledge to help other communities start recycling urine. As the Chief Technology Officer of Brightwater Tools, which develops technology for productive sanitation, including patented freeze concentration and pasteurization equipment for producing concentrated and sanitized fertilizer from source-separated urine and vacuum-flushed black water. So Abe, come on up, get your presentation.
Thank you, Julia. And thank you, everybody who came to this event. It's so exciting to see people interested in this topic and ready to learn and share their own knowledge and get more engaged and informed. So thank you all for making this event possible through your presence. I have quite a few notes here. It's a new presentation for me, so I'm going to be doing a time check as I go. So that's my second screen here is for. But yeah, the topic is tools in the toolbox. Urine diversion is a tool. The toolbox of nitrogen removal has other tools in it already that are appropriate, more or less appropriate in different settings. You know, there's IA systems, the on-site systems that remove nitrogen from a septic system. There is urine diversion, there's black water diversion, which has not been a topic that's come up much on the Cape, but something I want to speak a bit about today. And of course, there's also sewering. The central fact that makes me so interested in urine diversion and black water diversion that I've dedicated my professional life to it is the fact that most sewage, most wastewater is not human waste. It's mostly water. It's mostly tap water that we use in our sinks, showers, wherever. There's a tiny bit of human waste, about 0.42 gallons every day that we make, and that goes and mixes with everything else and turns it all into sewage and turns it all into this amorphous material that then has to be managed and handled. But if we drill down and look at what is happening with nutrients, it points out why urine diversion and black water diversion are so relevant. With the volume of wastewater, the pie chart is wastewater as a whole from a house. And so volume, as we just showed in the last slide, is mostly water, a little bit of urine, and a tiny bit of feces. But if you look at where the nitrogen and phosphorus in that wastewater are coming from, about 3/4 or more of the nitrogen in wastewater is from the urine, and another 5 or 10% of that nitrogen is from the feces. Phosphorus, likewise, about 2/3 are from the urine, and about 1/4 from the feces. So the nutrient pollution problem, whether you're looking at nitrogen or phosphorus, is a human waste problem, is essentially where it is. 80% of the issue is a human waste problem. If we can manage that human waste separately, we can solve 80% of the nutrient pollution problem on Cape Cod or anywhere. There we go. So as Jimena was mentioning before, or is it Julia? Sorry. The Rich Earth Institute, we founded that about 13 years ago now in order to address this issue. We wanted to create a world with abundant clean water and fertile soil and achieve that by reclaiming the nutrients from our bodies, you know, as part of the life-sustaining cycle. And we do that through education, research, and technological innovation to advance the use of human waste as a resource. So that's what Rich Earth Institute was founded to do. This moment here with you all is kind of a milestone for us, because this is a point where all of our work, over a decade of work on figuring out how to manage urine, how to recycle it beneficially, we're sharing that with a community that is actively engaged in exploring that as an opportunity, as a strategy. So how do we do it? At Rich Earth, we do this in a variety of ways, and part of our method for developing these methods and these technologies has been to try a lot of things and see what works and what doesn't work, and the things that don't work, see how we can tweak those, the things that do work, see how we can streamline them. So we've come up with several methods that we use to collect urine. The simplest one that we started with is simply a portable urine collector. It's made out of available parts. It's a 5-gallon container. You can put it anywhere. No real commitment to using it, but it's a lot of involvement in managing it, and that is something we still use. And I got a couple slides to illustrate it. People still have these portable urine collectors. They have tight sealing gasketed tops. They bring them to a depot, pump out with a vacuum pump, go home and repeat. But we also do permanent installations, often with porcelain fixtures, but a variety of fixtures that exist, some of which you'll be seeing today and tomorrow. And these fixtures are permanently installed in a home or a business or a public place, and the urine from that fixture goes through a dedicated drain to a urine tank, and then we come in a truck and pump it out. There are options for the trucking. This top option represents a hauler that you contract with. We originally did that. A hauler would wash out a truck they had, a hauling truck, and they would collect urine with it and bring it to our location. You also could have a dedicated trailer pulled by a multi-purpose truck, or what we now have is our own truck that has a urine pumping system and tanks on it that we can bring the urine either from the depot or from people's homes in their tanks and bring it to either a central treatment location, in our case it's at our research facility, or it could go to the end use site, go to the farm site and be processed there. We used to do it that way. Now we bring it to our central facility. We pasteurize it. That's something that I'll get into in a bit, but that's to destroy any pathogens that might be there. And then we distribute it to the farmers who apply it. So those are the steps. That's the process. These are not the only ways to do it, but those are the ways that we have been piloting. So to move on to the details of that, I'll hop into where we started with the very low tech, very low cost, very low commitment method, which was the portable urine collectors. And you may have seen these. These I know also exist on the Cape. These people can pick up, they can try out the idea of urine diversion. Some people like this system, want to use it for a long time. Some people see this as a way to try it, and then they want to do a permanent system in their home. But the way they work is there's a plastic ball that sits in the funnel, and that prevents gases from coming up, causing odors in the room. You can also add a little vinegar or citric acid before you start filling it, and that completely neutralizes any odors. And that's a very simple system. For under $100, someone can have multiple jugs, so they can always have one in service, and try it out. And yeah, I'll get back to that later as well. This is where in Brattleboro where they bring it to. It's a depot. There's a spot there you can see where you can, in the little white square, you place the jug, and the wand comes and vacuum pumps it out into this series of connected tanks in an insulated container, an insulated containment area. Then we pump it out with the truck. That's the low-tech version. The permanent installation, the higher aesthetic, the lower user involvement. This is also easier to convince authorities, health authorities, that it is a conventional or an alternative to a conventional method. Is not as far of a stretch to go, is to just use a different fixture. And these are all porcelain fixtures that you can permanently attach to a building that have a separate drain for urine that goes down to a urine tank. This first one, it has a divided bowl. It's easy to see how it works. The urine drains out the end, the front, everything else flushes out the back. The Laufen one is innovative because you can't actually see a divided bowl. It's got this little lip here, and the urine goes around by surface tension with the teapot effect and down into the urine drain. But when you look at it, it looks like a regular toilet, and everything else flushes out the back. And then that last one is for if you have a dry toilet or a composting toilet. It's a urine diverting commode that then connects to that composter, which is actually a composter is a full Blackwater diversion system, which I'll get to in more detail. These are all made in Europe. The flush ones are plumbed for European like dimensions and locations, which means that you have to do quite a bit of surgery to change the plumbing of the house to fit them. We're really excited that there is a company that is working on and will very soon be sharing information and actually trialing urine diverting toilets that are made for the American plumbing dimension. So it's just a drop-in replacement. And they're keeping that a bit under wraps for now, but we're very excited for more news on that and for that to become part of the equation, because that will really change things to have something that can be retrofitted for a regular American toilet on regular American plumbing. There are also other fixtures, other urine-only fixtures. So the one on the left here is made by the company Cinderella. It is a urine-only toilet. So it's a toilet that you can stand or sit on. You can stand and pee into it, or you can sit on it and pee into it. And so that's like, you can have a secondary toilet that is for anyone to pee in. And then the pee pod is developed by the Green Center, by Earl and Hilda, who are in attendance today somewhere, I think. Oh, right here, right in front of me, where I went not looking. Based on an earlier version, they made a lot of major improvements, and that you'll be able to see today and tomorrow as well. It flips into the wall, so it's hidden. You pull it out and can use it as a urinal. So these are a lot of different fixtures. There are even other ones, but these are the ones that we tend to use the most or are most excited about. Where does that urine then go? So it goes down this is a Vermont drawing. So this is approved by Vermont Department of Environmental Conservation, and the plumbing board allows us to install them like this. For Massachusetts, there are some changes because plumbing codes are different. But the gist of it is the same. Urine comes down the dedicated pipe into a storage tank, ideally in the basement. And that tank is vented to the outdoors and has a pump out port so a truck can pull up and just evacuate it into the truck without having anyone going into the building necessarily. There is an overflow valve with a backwater valve to prevent it from sewage coming in. That is in case service doesn't happen on time. If the tank is filling, you don't want it to overfill in the basement. You want it to go out into the sewer or into the septic system. Now that would be discharging nitrogen, and that would not be then collected, but the normal operation is there's an alarm that goes off before the overflow happens, so then you get the service to come and pump it out, and that's the prevention for the overflow. The overflow is really just a last protection so that you don't have any issues in the basement if service doesn't happen on time. So we have many of these installed in Vermont in our area. They can be installed throughout the state. It's a statewide approval, and so they can be installed in the state, and then any organization or any entity that is approved to be collecting urine and processing it, which in Vermont is the Rich Earth Institute and Wasted in Brattleboro and Burlington respectively. So there's two organizations that can do that service, and hopefully more in the future. That it's approved, and then on an ongoing basis that service is done by that authorized provider. So it's a fully authorized process all the way from the installation of the toilets to the collection and the use of the urine. Here is the pump out happening. Arthur Davis is in that picture. He's here somewhere today, right there. You'll be hearing more from him about how the operations work, but that gets pumped out into our truck. You could use a regular vacuum pumping truck. Wasted has a vacuum pumping truck. Because urine is easier to handle than sewage and septic, we can have all kinds of foreign material in it. We are able to pump it with more conventional pumping equipment that is potentially like a lower setup cost. Not sure if that's a deciding factor, but that's something we've been working on and developing over the years. And that's our truck, obviously, that we haul urine around in. We put tanks in the back or take them off depending on what we're doing that day. Then we pasteurize it at 80 degrees Celsius for a minute and a half, give or take. And that's a process that the EPA approves for treating of wastewater, sewage sludge, all sorts of really high pathogen materials. This is a method that is approved for producing a product that can then be used as fertilizer. So it's perhaps overkill for urine because urine is very low in pathogens, but with these divided bowl toilets, there's always the chance for some fecal pathogens to end up on the wrong side of that divider and end up in the urine. So that's why the state requires it, and it's a good precaution. When people use pure urine they collect at home in gardening, that's not really an issue, but for this kind of community scale process, that's a requirement for us. And then we apply it as fertilizer on local farms. And typically it goes on hay fields. That we have a lot of hay fields very nearby where we are. If we go under 10 miles, we can get to hay fields that need urine. They need more urine than we can supply. So that's a great outlet for us. We've also have used it on corn, on sweet corn, on field corn, on hemp, flowers, figs. We have partner farmers that do research with us. So we've used it in a lot of crops with lots of positive results. But you may not always be in a place where the urine can be used nearby. Cape Cod is a place where you have an overabundance of nitrogen here. There are people bringing nitrogen fertilizer onto the Cape and using it in agriculture or for other reasons. It may be that some of the fertilizer imports could be offset by using urine locally, but ultimately I think there's more urine being generated on the Cape than can safely be used without defeating the purpose of collecting it. So how can that urine be transported farther? One option is to concentrate it into a more dense fertilizer that is then easier to haul and store and apply. And so this is the freeze concentrator, and you'll see all these technologies here because there's a demo here at MassTC. But this freeze concentrator reduces the volume by more than 80%, factor of 5 or 6, by partially freezing the urine into pure water and concentrated liquid fertilizer, and then separating the fertilizer out from the ice by draining it, and then melting the ice to get a water product, separating water from fertilizer. And then there is an option to carbon filter that product, because people often say, well, what about the pharmaceuticals in urine from drugs people take? What about PFAS? Is there PFAS in urine? And those are questions that always come up. We have done at Rich Earth a good bit of research. We worked with Dr. Nancy Love here on the side at University of Michigan for many years on a research project with looking at pharmaceutical residues in urine. And we determined by measuring the natural occurring pharmaceuticals in urine, and also by spiking additional pharmaceuticals, testing it in soil, testing it on crops grown in the soil, that the actual amount of pharmaceuticals that get through to the crops is vanishingly small. For instance, it's ibuprofen, naproxen, acetaminophen, the caffeine, the drugs people take often over the counter, or recreational coffee drinkers end up with those at the highest concentrations in their urine. That's what we were able to measure at very small amounts in the crops. But the levels were such that you'd have to eat hundreds of thousands of pounds of the vegetables to get a single dose of any of those, or eat a normal amount for, say, 1,000 years. So vanishingly small amounts, but it's a question. It's a policy question. It's a political question. It's a psychological question. Also, this is not the end-all and be-all of research. Always more studies can reveal new things. So this is a method you can use to polish the urine. We don't necessarily say it's necessary, but it is definitely available, and maybe it's the right thing to do. We're not the authorities on that part. So you've seen a lot of slides just now with Brightwater Tools branding. Brightwater Tools is a spin-off company of the Rich Earth Institute, formed about 5 years ago, and Kim Nace and I founded that as a spin-off. Jackie Gold, standing up over here in the orange, is also a part of the company as a strategy officer, and they'll be here representing these tools. I also can as well, but they'll be here showing them off and exclusively focusing on that. I wanted to make the point of what Brightwater Tools is and how it's connected to Rich Earth. So the reason we created Brightwater Tools is because Rich Earth is a basic research, demonstration, education, policy outreach organization. We do a lot of proof of concept and first prototypes and building things, our systems that work well enough for us to do our demonstration project. But we needed to make a spin-off company to actually commercialize any of these. So to make a product that was a high enough point of development, that was reliable enough once it's out of our hands, that it could be sold and used in the setting of say, a municipality that wants to recycle urine. So, and disclosure, Kim and I are both part owners of that. Rich Earth Institute is also part owner of Brightwater Tools. So there's a connection that we should make sure to be explicit about. The items on here are a freeze concentrator, a pasteurizer, carbon filter, and a struvite maker. You can see for scale the size of these barrels. That's barrels about half as tall as a person, roughly. So this equipment is about person-sized. The first one is the freeze concentrator with a heat pump next to it. So these two things work together to bring in raw urine, concentrate it down by a factor of 5 or 6, and then it goes through a pasteurizer, and then it can optionally go through the charcoal filter and then out into the fertilizer storage tank. The struvite maker is another optional piece. Urine contains nitrogen and phosphorus, and if you want to separate those two and have a liquid nitrogen fertilizer and a solid phosphorus fertilizer, the struvite maker does that. And that just depends on who is going to use the fertilizer and what their needs are. Several of these are patented. As you can see, they've done a lot of research into these technologies. It started at Rich Earth, and then Brightwater has taken that to a high level of sophistication. So they're ready. These items are all for sale, all in use out in the world. then what do you do with that fertilizer? What good is it? What value does it have? That's a hard question because urine fertilizer is not a known quantity out in the general commodities world. But there are things we can compare it to. So one of those things is liquid fertilizer made from fish or from seaweed. That's the closest we found that actually approximates urine in its composition. And the important thing about them is to look at the price per kilogram of plant nutrients, because that's how we can equalize all of them. And this is the lowest cost we could find anywhere of a fish fertilizer. It seems like it's just fish waste mixed with sulfuric acid. So kind of an unusual mixture, low-cost mixture. The other ones, these are hydrolyzed. It's a more sophisticated process, apparently, and ends up with a product that has a lot more dollar value. But for comparison, from around $50 to around $200 per kilogram of plant nutrients. In comparison, something like blood meal, which is a solid material, is only about $27 per kilogram of plant nutrients. So there is a spread. I think the liquid fertilizer, you can use it for things. You can't use a solid fertilizer. It can go through irrigation systems. It's more available immediately. So it commands a higher value. Urine would be somewhere in there. We don't know where it would be, but I'll use later cost estimates. We'll use that $46 because that's the most conservative, least ambitious thing to estimate. So how much nutrients are we talking about in urine? What's really in there? There's a lot of nitrogen in urine. There's close to 6,000 milligrams per liter compared to about 30 milligrams per liter in regular sewage, so about 200 times more dense than sewage, which is why we care about urine, why we want to capture it. It varies from person to person over time, but it is within that general range. How much can you collect from a person? This is a graph for 1 year in 2022 of all the people that used our depot, so those portable urine collectors. Everyone who came there, how much did they bring? And it's a huge range. People over here, they were dedicated. They did. Maybe there were a lot of people in their houses. I don't know. Some of the folks down here had one of those collectors in their studio they worked in, or in their garage, or they just had it for when the bathroom was full and they needed to use the toilet. They had it, and they'd only have we have a couple people with maybe, what is that, 2 gallons or something down there. It's a big range, and this is all voluntary. There's nothing in Brattleboro that is like an imperative. You will get a personal benefit from using urine diversion. People did this because they wanted to recycle urine. They thought it was a good idea. This is an aggregation of how much we collected. The bottom line there is if you look at the top 50%, the people who are actually collecting any substantial amount, it was about 3 kilograms of nitrogen per individual who was coming there, which we say represents a household. Although it may have been just one person, they like to do it, but their spouse was like, no, I don't really want to use that funny thing. So it's hard to really gauge how many people were using it, but it was around 3 kilograms per individual who was filling out our sheets. Important to note down here, Green Center and Mass TC did a study a couple years ago with a similar arrangement with those portable collectors, and found a considerably higher number, 4.4 kilograms per household. I wonder what that says about the urgency people here feel about keeping that nitrogen out of the wastewater and the commitment that people have to the idea of doing what they can. So that's a significant number, and that's done with this kind of laborious device that you have to really tend to and get used to, as opposed to a plumbed fixture. These are plumbed fixtures. These are fixtures that have been installed at this point for each of them for multiple years, and you can see the gallons collected per house varies greatly. It's somewhat connected to how many people are in the house, but not really entirely. It's connected also to how much people are home, how much they use whichever fixture, and the green graph is how much per person was collected. So you can see that varies quite a bit as well. So it's not like a certain amount per house. It has some variation. I do want to point out, house 2 is the only house that had 2 urine fixtures in it. The other houses all had a single urine fixture in the whole house. So there has been some conversation in the Cape about like how many fixtures do you need to have? Does it have to be all the fixtures? Can it be just one fixture? What is required in order to collect substantial urine? And clearly, like look at house number 5, 1 fixture, and they were getting 3 kilograms per person, and there were 4 people in that house. So that's 12 kilograms right there, one house in a year. that I'm repeating myself here. That's just a breakdown, average of about 6.3 kilograms per house per year. So let's get to what's the cost, and imagining what it might be on the Cape. This is something I've spent quite a bit of work on pulling together figures and running estimates on high and low end of what the costs might be. This first line up here, credit on this line, goes to folks who have been involved with the MassTC-led pilot project planning. So that's MassTC. It is Point of Shift. It is Matthew Lippincott from University of Michigan. It is Connor Lally from Nutrient Networks, who did a lot of legwork on the plumbing costs that are in this line here. Also, Rich Earth was involved as well. So these plumbing costs are an estimate of 1 toilet on the low-cost side, 2 toilets on the higher-cost side. The low-cost side assumes some lower unit prices versus higher unit prices. There's also how much will it cost to haul the urine. The estimates between the vicinity of $1 to $2 per gallon pumped, and that estimate may come down in time as this becomes more of a known quantity. But I used in this column the $1 and the closer to $2 in this column. Those may actually end up being lower as this rolls out, but I didn't want to make any assumptions. So it works out for the installation, the onset costs for installation and for pumping over a period of 20 years. They're actually kind of the same amounts each in the low and high cost, around $7,000 something or around $16,000 per category. So it comes out to around $15,000 or around $32,000 for the actual building installation and pumping costs over a 20-year period. Processing to fertilizer, I assumed the Brightwater system because I have numbers, I have figures for that, but it could be, some other system. But with that system, it would cost about $27 to $34 per household per kilogram of nitrogen managed. And then the fertilizer sales, this is a negative cost if we assume that $46 per kilogram of value for the fertilizer, or it's no change if we say, well, maybe we can't sell that as a fertilizer. Maybe that's just something that is given to farmers at no money changes hands. So the total cost per kilogram of nitrogen removed is a wide range, $73 to $317 per kilogram. It's a very big range. Clearly, we need to narrow this in. This is like the kind of worst case, best case, so the truth is probably somewhere in between. But until we have actual implementation, we can't nail those costs down precisely. What we can draw from this, though, is that $73 is far and away a lower cost than anything else being discussed for wastewater on the Cape. $317 is sort of in the mix with other options. So it seems like with this analysis, it does not look to me like urine diversion is in any way ruled out. If anything, it is it's suggestive that it's very cost competitive, but that range means that it's not clear. It's not clear until we have actual experience where those assumptions will break out. So that was urine diversion. Let's zoom back out again, look at our pie of nutrients, and say urine diversion is a fraction of this. It's not all of this, because with a urine diverting toilet, not every drop of urine is going to fall into the urine collection. So it will be some fraction of this, maybe most or almost all of it if you have conscientious users. But this part will not be part of it, and whatever fraction that is remains to be seen. If we did full toilet waste diversion, full Blackwater diversion, then all the yellow, all the brown would be captured by the toilet technology, and only the little sliver of the gray, well, not sliver, but that 20% or so of the gray would be going through. And if that happens, then the nitrogen removal rate is on par with a lot of nitrogen removing septic systems, even on par with good nitrogen removing septic systems. So taking all the Blackwater out is roughly comparable to using a good nitrogen removing septic system. But how would you do that? How do you take out all the Blackwater? It's not with a urine diverting toilet. There are a few examples. Ones that have been discussed and demonstrated on the Cape already are composting toilets, incinerating toilets, and packaging toilets. Microflush toilets with storage tanks have not been much discussed. And that's one that I've become increasingly interested in. There is a vacuum flush toilet in the bathroom right there behind Brian and Amy Amy is pointing to, Brian is pointing to, encouraging Gretchen. Everyone wants you to try that toilet. It is a vacuum flush Jets toilet. And so it uses vacuum flush, but it is much quieter than what you might have experienced, like say on an airplane or on a train. These are used in cruise ships, and also in Europe. I've used them in hotels. They're used in homes. If you use that one, and you want to see how quiet it can be, use the toilet, close the lid, push the button. I think you'll be pretty surprised at how quiet the sound is. It's not any different from a regular flush toilet to my ear. So it uses about a quart of water to flush, which means that over a course of a day, you might collect 2 gallons of material. If you have that works out to be over the course of a year, about 700 gallons per person. If you had 2 people in a home, that's 1 or 2 pump outs of a standard size underground tank. So it is in the realm of what would be reasonable to do service on, and it would capture all of the black water from a house. Now, it's definitely more costly and more involved than, say, installing a composting toilet, which accomplishes the exact same thing in a smaller footprint, a lower cost, and a more straightforward sort of installation plan. But a composting toilet isn't adaptable to every house. Not everyone wants a composting toilet. So it is another tool in the toolbox. It's not the best one on this list. I don't think anyone is the best one. They're all just right for different people in different scenarios. But that micro flush black water diversion or any other black water diversion, composting toilet, incinerating, packaging toilet, they all fall in this category that I call black water diversion. So this is just a little kind of coming to the summary of the presentation. Where do these things fall out? How do they relate to each other? 4 different terms that they differ on. With the urine diversion, how easy is it to quantify nitrogen removal? It's very easy because you pump out the urine, bring it in the truck back to wherever it's being processed. You can measure the gallons. It's a simple grab sample and an inexpensive test. Tells how much nitrogen is in there. And you can calculate exactly how much nitrogen is in that tank of urine that's been diverted from that watershed. And Mass DEP, with Mass TC and the urine diversion pilot study planning process, we've talked with people at Mass DEP, and they are very favorable for this idea of direct quantification of nitrogen, because it truly tells how much nitrogen is being removed that would have gone into septic and instead is being redirected. So it's the most accurate way to actually know what's been accomplished. Same holds true for black water diversion. You can sample it because you've collected all of it. With an IA system, an on-site nitrogen-reducing septic system, it's much harder to quantify that because you have to do an elaborate, maybe not elaborate, but a very involved multi-year test at multiple sites to be measuring what's going into the tank, coming out of the tank in different seasons with different occupancy in the home, and inferring from those numbers how much is being removed by the tank, then trying to develop a benchmark for this specific system. If it's used correctly, if it's operating right, if all the parameters are the same as our tests, then expect comparable results. So it gives a sort of a rule, like a one-size-fits-all number for a house with this IA system might be removing 7 kilograms of nitrogen per house per year. And that number is then just applied. Hopefully it's accurate for all the houses it goes on. And it's the best you can do with that kind of system because just the nature of the system. But it's a big advantage with urine diversion and black water diversion. You actually have the material, you can measure it, you can quantify it. So in that way, it's actually quite superior in terms of quantification to what we've been used to with IA systems. Can it be implemented with a single toilet fixture? For urine diversion, it can be. It doesn't have to be. Every toilet in the house can be converted, but as I showed in those slides before, you can get very high levels of nitrogen recovery with just one fixture in the house, which helps to keep the cost down. With black water diversion, you could also do the same thing, but you don't have to. You could convert all of them. With an IA system, you can't do it by just changing a fixture in the house. You have to install something significant in the backyard of the house or in the environment of the house. A lot of site work is involved, and it manages all the waste. It's sized to manage all the waste from the house, which is an advantage in a sense because it handles everything, but it's a pro and a con because it also means that it's a whole different intervention. So that's why these are tools in the toolbox. If you have a backyard with nothing there and a great spot to put a tank, and your plumbing is all like the right configuration, then maybe putting in an IA system there is the most sensible direct thing. If you've got a patio there and you've got all kinds of grounds and you don't have any space anyway, but you have a basement where you could put a tank and a urine diverting toilet, maybe that's the best solution. So this is not to say who is best, but just what are the advantages and disadvantages of the different systems. It treats all the toilet waste. Urine diversion does not. It just treats the urine, obviously. And the Blackwater diversion, it can if you have all the toilets converted, or it cannot if you only converted one toilet. So it's kind of a middle of the road there. With IA, obviously, it gets all the toilet waste because it gets all the waste from the house altogether. And then this one, performance is independent of toilet user behavior, meaning that the system will work the same no matter how someone uses the toilet. That's not the case for a urine diverting toilet, because you have to use the toilet properly. If you know, for instance, if someone stands and urinates into the back of the toilet and flushes it out the back, that's not using it properly. It's not going to function right. With the Blackwater diversion, as long as you have converted all the fixtures, it gets all the toilet waste. You're not going to have any toilet waste going anywhere else, whether that's a vacuum flush toilet or a composting toilet or something else. And for the IA, of course, how you use the toilet doesn't have any impact on the IA system. This area here, I think, is an interesting area to think about. The Blackwater diversion, you can implement with a single toilet fixture, but then it still leaves open the question of will people use that one almost all the time, or will they use the other one most of the time or some of the time? And that question makes it impossible for a regulator to say, like, okay, this is a system we know how it will perform. And that maybe is a distinction. I can get into that with the Q&A or after the presentation. We need to talk about it at some point, because on Cape Cod, in terms of regulation, it's significant whether an alternative, like a source separation system, a urine diversion or a Blackwater system, is considered like an IA nitrogen reducing, especially a Bannert system of best available nitrogen reducing technology. I may have missed a word in there, but that's the topic. Whether it's considered that or not, and that's a whole other conversation. I was going to put it here, I took it off. I don't want to get there on this slide. But the Blackwater diversion, I think, does have a lot of potential to qualify as a nitrogen reducing on-site wastewater system, whereas urine diversion is, I think, more suited for having it be a low-cost system. Maybe it's only one fixture, removes a large amount per household that counts toward the watershed management goals, but doesn't have to necessarily qualify as an on-site system for managing the nitrogen emissions on the actual location. I think that'll come up a lot more in this summit today and tomorrow, but that's just a topic that I want to introduce because it's an important one. So, wrapping up, nitrogen recovery. Sorry, the stopper only goes halfway across here, so the thing is slide off the edge. Any nitrogen removal or recovery system on a household level will vary in how much nitrogen it captures because of household variations. You know, there's the number of people in the house. Is it a seasonal home? Is it a year-round home? Are the people home most of the day? Are they away most of the day? Do they entertain? So there's a lot of variation. Those make variation for urine diversion, nitrogen collected, for Blackwater diversion, also for on-site advanced septic systems, and for how much goes into the sewer. Like any system will vary in how much nitrogen is collected, and that's something that people think with urine diversion. Well, you know, that could change depending on the household. It actually applies to all of them. So I think that's none of those are an obstacle for urine diversion, for adoption or quantification of urine diversion, because they apply to any house. You can't know from a house each house will emit this much nitrogen. It's assumed in modeling, but it's not actually what happens per house. There are some variations with urine diversion that are above and beyond those. So those relate to how many toilets are in the house. Are they all urine diversion or only some of them? So is someone using the urine diversion toilet or the other one? Which do they choose? And then also how effectively do they use the UD toilets? And those are questions that are very hard to answer, if you have a regulator who is saying, well, we want to have a number per house, for our model, how much will be diverted by urine diverting per house? And if someone, if the municipality says, okay, we're going to have one toilet per house because that's the lowest cost option, and we can do the most houses that way, the regulators are going to say, well, how do we know we're going to use that toilet? No, we can't. But that's why the saving grace is that direct quantification of the urine that's collected means you don't have to know how much the toilets are being used, how many occupants. You don't need to know anything about the house or how it's used. You just need to know how much nitrogen is actually recovered in the urine, because that number drops directly into the municipality's calculation of how much nitrogen have they diverted. So it's a question people bring up sometimes thinking this is a problem, but actually turned on its head, it's like, no, there's a much better way to quantify nitrogen from urine diverting that you can't apply, which is why those complex models exist for IA systems. For urine, you just go directly to the answer, how much was collected. So what that all boils down to is there are some questions left. There's some burning questions left around urine diversion, potentially around Blackwater diversion. How much can be removed per house by urine diversion or by Blackwater diversion? You'll be hearing throughout the day about models, and I threw up some numbers. I should make a distinction here. I threw up some numbers about how much was collected from houses. 4 kilograms, 6 kilograms, and so on. You'll hear later today, very soon I think, model assumptions that there are 11 kilograms of nitrogen in a house's effluent. Those numbers don't go directly together because that 11 kilograms is an assumption. What we measured, we don't know how much the house was actually making. Those houses all made different amounts. So bear in mind that these numbers cannot all be stuck together and done arithmetic with. These are more just ways of calculating what fraction is from where. But by actually doing it and measuring it, we can find out what's actually possible and true on the Cape. How much variation, you need to find that out as well. And what's the cost? What's the actual cost once you've hired the plumbers, done the permitting, gone through the entire process, installed it, worked with the haulers, done maintenance? What does it actually break out to cost per house? That remains to be seen. We need a pilot study, and that's the only way to know what it will cost. And I'm just so glad to be saying this at a point where there is a pilot study in the works. There's been funding from multiple sources. There's interest throughout the town and throughout the Cape at large on the question in general. So it's an exciting moment because these are the questions that, what I've shown you is as much as we can tell you of Rich Earth's experience that bears on the Cape, but it's exciting to know that there's a trajectory where these numbers may soon come from real world experience right here. So I will wrap that right there, and thank you all for your attention. Okay. Sounds like I only left 4 minutes for questions. I'm sorry. Any questions? Fastest hand in the West, yeah.
Part of the study, the first study here, and one thing about us was that we didn't have to take it to a deep end.
Right.
So presumably, if we were following the rules and using the tank that we had, our measure was pretty good.
Right.
And the other is just always like, what do you do with the waste?
That's the biggest thing people talk to me about when it comes up, like, well, what are you going to do with it? And I was recently at a place where they installed a composting toilet, and I said to the person there, well, what are you going to do with that? And she said, oh, they haul it away. So it seems like there's similar issues already in place with, like, who's hauling the stuff from the composting toilets away, and where is it going? And what are those problems?
Yeah, it's a great question. I don't know, who was hauling that or where they were taking it, what they did with it. With the urine, it can be converted to fertilizer, and that's what we do, in Vermont, and that's, I think, there's a lot of interest in that in terms of turning it into a useful resource, maybe even some potential income from that. Through making a fertilizer and selling it, although it would only offset a portion of the costs in any case. But yeah, the question of where it goes, it requires farmers who want it, and I think that part of the work of a pilot study needs to be making those connections, and we've done that in Vermont, and as I said, we have more people who would like the urine and more urine than we can supply, but those connections need to be made here, and establish that there is the same demand here, but it only takes a few farms. It does not take a lot of land to use the urine, because so much fertilizer is required in agriculture that urine can only replace a portion of that. One more question. Oh dear. I can't. Okay.
Discussion after the panel as well, so there'll be time for more questions then.
Well, let me just count. Raise hands, and I'm going to count to 8 on the hands and see where I get. Raise your hands up. 1, 2, 3, 4, 5, 6, 7, 8. Hilda.
I can give a quick answer. The solids of a person composted, a person with paper and shavings makes about 1 bushel a year. You're not talking a lot of material, and it's composted after 2 years. You can use it on any material. You can put it in your backyard. You don't have to haul it off. It's only 1 bushel, so that's an easy one. But the other one no big discussion, just the one thing that doesn't come up is the externalities. The stuff like the climate change, the greenhouse gases, the water savings, the whole thing that you have with sewers, where it's going to go, the incinerators, the toxic waste, and all that is not part of urine diversion, luckily. So all the externalities that are so expensive and not included in these calculations are all favoring urine diversion, and gray water, black water too.
Thank you.